Okay, so now we move on to the very last part of this matrix chapter. So last thing you are learning here is to reduce a symmetric matrix to diagonal form. Okay. So look, there are a few things that you need to know here. The first one is, if M is a square matrix such that M into M transpose is equal to I, then M is called an orthogonal matrix. So please have a look at this word. So what is this? M multiplied by M transpose. Basically, you take a matrix and multiply by its own transpose. If you multiply a matrix by its own transpose, and if you get the identity matrix, such matrices are called what matrices? Orthogonal matrix. So you must, I know the meaning of this word. Orthogonal means you multiply a matrix by its transpose and you end up getting the identity matrix. Is that clear? So if M is an orthogonal matrix, then M inverse is equal to M transpose. So this is a really important property in an orthogonal matrix. So they will give you in the exam saying this is an orthogonal matrix. So if they do give you an orthogonal matrix, what's the advantage? The inverse matrix is directly equal to what? The transpose, because normally, when you multiply a matrix by its own inverse, you're supposed to get I, right? But here they say M multiplied by M transpose is I. Are you getting what I'm saying? Which means what? Which means indirectly M inverse and M transpose are the same. So thereby, if by any chance in the exam they use this word, and if they say this certain matrix is orthogonal, what do you realize? Do you need to go through all those 5, 6 steps to get the inverse matrix? To get the inverse of a 3 by 3 matrix, the process is quite long, isn't it? But if it's an orthogonal matrix, the inverse matrix can directly be found by what? Just by taking the transpose. Can you see the shortcut here? There's a major shortcut, because finding the inverse is usually a very long process. So, but if it's an orthogonal matrix, we can find the inverse very easily. Are you with me? Okay, then look. Two eigenvectors x1 and x2 are orthogonal if they are scalar products. X1 dot x2 is 0. You learned in Q4 that if non-zero vectors have scalar product 0, they are perpendicular. Perpendicular and orthogonal have the same meaning in this context, but it is customary to use the word orthogonal when referring to eigenvectors. Do you see the meaning of the word orthogonal? Orthogonal means that the vectors are perpendicular. But they say in here in PO4 you use perpendicular, but it's customary in F3 that we use the word orthogonal, not perpendicular. So if M is an orthogonal matrix consisting of normalized column vectors x1, x2, x3, then x1 dot x2 equal x2 dot x3 equal x3 dot x1. So this is a really important phrase here. Okay, so if you have an orthogonal matrix consisting of normalized column vectors, in that case, if you take the product, the scalar product of any of the column vectors, it will make it 0. Are you with me? And then they say a diagonal matrix is square matrix in which all the elements which are not on the diagonal from the top left to the bottom right of the matrix are 0. The diagonal from the top left to the bottom right of the matrix is called the leading diagonal. Okay, so again, a really important phrase. So there's a lot of theory here, but the question is quite simple. Okay, so you don't have to worry about all this extra theory load, but it's just something that you need to know. Diagonal matrix is a square matrix in which all of the elements which are not on the diagonal from the top left to the bottom right of the matrix are 0. So as an example of a diagonal matrix, what's an example? So every element is 0 except the ones on the diagonal. Are you with me? So this is a diagonal matrix. The diagonal has elements, but everyone else is 0. Are you with me? So again, another example of diagonal matrix. Can you see? Only the diagonal has elements, every other element is 0. Are you with me? Okay, so these are some examples of diagonal matrices. And then the last part is we learn how to reduce a symmetric matrix A to a diagonal matrix D. Okay, so what are we going to do? We are learning how to reduce a symmetric matrix to a diagonal matrix. So look, the first thing you do is find normalized eigenvectors to A. Okay, so write this down and I will show it to you in an example. To reduce a symmetric matrix A to a diagonal matrix D, use the following procedure. So you will write down, find normalized eigenvectors of A, form a matrix P with columns consisting of the normalized eigenvectors of A, write down P transpose, the transpose of the matrix P. A diagonal matrix B is given by P transpose times A times P. So just write this down and I will explain to you. I think the best thing is that we do it from an example. Okay, how we can end up getting a diagonal matrix by using a symmetric matrix. Okay, so I will show it to you in an example in a moment. For now, we'll read the remaining part. They say when you reduce a symmetric matrix A to a diagonal matrix B, the elements on the diagonal are the eigenvalues of A. Okay, so this is extremely important. Can you look at this? When you reduce a symmetric matrix A to a diagonal matrix B, the elements on the diagonal are what? Are the eigenvalues. Can you see there's another way to get eigenvalues? So to get the eigenvalues, if you can find the diagonal matrix, you can get the eigenvalues. Are you with me? Okay, then the last point for any symmetric matrix A, the matrix P is an orthogonal matrix, and so P transpose is equal to P inverse. Okay, orthogonal means the inverse matrix can be found by the transpose. So it follows that P transpose AP. Now you found that we wrote here that the diagonal matrix is found by P transpose times A times P, right? So P transpose times A times P can also be written as P inverse AP. Why? Because P transpose and P inverse are the same. Okay, so that's the last point. Okay, now let's actually go for the question and see how to find the diagonal matrix. Okay, so let's work on this. Okay, so exercise 6G question number 1. Look, reduce the following matrices to diagonal matrices. Okay, they are asking you to what? Reduce the matrix to a diagonal matrix. Are you with me? Okay, so what's the first thing we should do? Read step 1. Step 1 is what? Find the normalized eigenvectors of A, right? Now, how do we find the eigenvectors? Ax equals lambda x. Do Ax equal lambda x? What do we need? We need to find the. Can I directly go Ax equal lambda x? What do I need to find the eigenvectors? I need to know the eigenvalues. How do I find the eigenvalues? By getting determinant of A minus lambda equals 0. Are you with me? So A is 1, 3, 3, 1. Are you with me? Who is A minus lambda? If it's a 2 by 2 matrix, your identity matrix is 2 by 2. What do you get here? 1 minus lambda 3, 3, 1 minus lambda. Are you with me? Determinant of A minus lambda is multiply. 1 minus lambda into 1 minus lambda, multiply the main diagonal minus multiply the other diagonal. 3 times 3 is 9. And you have to set it to what? 0. Are you with me? Open the bracket. 1 into 1 is 1 minus lambda minus lambda minus lambda minus lambda is plus lambda square minus 9. Are you all with me? I get here 1 minus 2 lambda plus lambda square minus 9. Basically, lambda square minus 2 lambda minus 9 plus 1 is minus 8. Can I know the lambda values here? Can you all solve? Solve the equation, get me the lambda values. Other lambda minus 4 and lambda plus 2. So which gives me lambda minus 4 equals 0 or lambda plus 2 equals 0, which gives me lambda equals 4 or lambda equals minus 2. So we got the 2 lambda values. Now by using the 2 lambda values, what should you do? Calculate the 2 eigenvectors. Are you with me? So for lambda equals 2, let's get the eigenvectors. Ax equals lambda x. Who is A? A is 1, 3, 3, 1, right? And x is the eigenvector. Since you're dealing with 2 by 2, your eigenvector will have only 2 elements, x, y. Lambda is 2, again you have x, y. Are you with me? Open the bracket, you get 1x plus 3y. Here you get 3x plus 1y equals to 2x, 2y. Are you with me? So the first equation reduces to x plus 3y equals 2x. I end up getting x equal 3y. The other equation also, I think we are getting the same thing. 3x equal y. X plus y equal 2y. Is that correct? Sorry, the lambda value is not 2, right? It is? What's the lambda value? Lambda value is minus 2. So this is minus 2x minus 2y. And you all fix the equation because it shouldn't be two different equations. What do we get here? 3y equal minus 3x. So I get y equal minus x. I think over here also it should be the same. 3x equal minus 3y, x and minus y, or y equal minus x. Can you see? You get the same thing. So who is the eigenvector? This is the invariant line under the transformation. So what's the eigenvector? Who is the eigenvector? If x is 1, y becomes minus 1. And then we don't need just eigenvectors. We need what eigenvectors? The normalized eigenvector. Can you get the normalized eigenvector? And I have the magnitude here, 1 square plus minus 1 square square root. How much is it? Root 2. So normalized eigenvector is 1 over root 2 minus 1 over root 2. Are you with me? Okay, likewise, what should you do now? Get the eigenvector corresponding to lambda equals 4. Are you with me? Get the eigenvector corresponding to lambda equals 4. A is 1, 3, 3, 1. X is xy. Lambda is 4 times xy. Are you with me? I get 1x plus 3y. I get here 3x plus 1y. 4x, 4y. So x plus 3y equals 4x. 3y equals 4x minus x is 3x. Y equal x. 3x plus y equals 4y. 3x equals 4y minus y is 3y. X equals y. Can you see? So this time the eigenvector is what? When x is 1, y can be 1, isn't it? So normalized eigenvector. Divide by the magnitude. Who is the magnitude of 1? 1, 1. 1 square plus 1 square square root is root 2, right? So 1 over root 2, 1 over root 2. Is that okay? Again. Okay, so to find the diagonal matrix, what was the first step in finding it? What was the first step? We did the first step. The first step is find the normalized eigenvectors of A. Right, so we did it. Normalized eigenvectors of A is done. Next, what's the next step? Form a matrix P with columns consisting of normalized eigenvectors of A. This is the second step, right? We just gave you. So matrix P is formed by the columns of the normalized eigenvectors. Who are the normalized eigenvectors? 1 over root 2 minus 1 over root 2 is the first column. The second column is 1 over root 2, 1 over root 2. Do you see how I got it? The first one I got from the normalized eigenvector for lambda equal minus 2. The other one I got for the normalized eigenvector for the lambda value 4. Can you see? What's the next step? Third step? Write down P transpose, the transpose of matrix P. So next step is to write the P transpose. Are you with me? Step 3. So how do you transpose? Just interchange rows and column. 1 minus root 2, it comes to the row. 1 over root 2 minus 1 over root 2 is the row. The second column becomes the second row. The first column becomes the first row. First column became the first row. Second column became the second row. Can you see? After that, what's the next step? Can I know the last step? A diagonal matrix D is given by P transpose times A times P. So let's multiply P transpose. Who is P transpose? 1 over root 2, 1 over root 2, minus 1 over root 2, 1 over root 2. Who is A? Who is A? 1, 3, 3, 1, right? A was our original matrix, isn't it? A is 1, 3, 3, 1. Can you see? Into P. Who is P? 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. Are you with me? Okay, now it's time to multiply. Actually, before you multiply these root 2s, you can see root 2 is common to the first entire, all the elements are having root 2, right? Shall I take a 1 over root 2 out? Then I get 1, 1 minus 1, 1. Can you see? 1, 3, 3, 1. Here also, shall I take a 1 over root 2 out? I get 1 minus 1, 1, 1. 1 over root 2 into 1 over root 2 is 1 over 2. So now it's time to multiply. You can use the calculator. Just make sure you show the intermediate steps so that you will get the marks. Okay, so I will use the calculator to multiply. So menu, matrix. So we'll define matrix A, B, C. Matrix A, 2 rows, 2 columns, 1, minus 1, 1, 1. So I define matrix A. So number 1, go define matrix. Matrix A is defined. Oh, sorry. Okay. 2 rows, 2 columns. Yeah, it's already defined. So then we go define matrix, go to matrix B, 2 rows, 2 columns, and then give the matrix 1, 3, 3, 1. Matrix B is defined. Define matrix, and now go to matrix 3, matrix C. So matrix C, 2 rows, 2 columns, 1, 1, minus 1, 1. Are you with me? 1, 1, minus 1, 1. Okay, so when you're multiplying, don't go to give me the matrix multiplication of everyone together in the calculator. What should you do? Half is out. First leave matrix A. Multiply first what? Matrix B and matrix C. Show the working. So the intermediate steps are there so that it looks like you have done this manually. So I will keep matrix A and multiply matrix B with matrix C. Can you see? Matrix B and matrix C are multiplied, and press the thing and get the answer. Minus 2, 2, 4, 4. Did you get the multiplication? Minus 2, 2, 4, 4. So this is the matrix answer. Now what should you do? This matrix answer you should multiply with matrix A. This is mat answer. Mat answer you should multiply with mat A. So multiply options. Matrix A multiplied by matrix answer. Can you see? Not with mat B, mat C, because mat B, mat C we multiply and got the mat answer. That answer you multiply with matrix and you get here minus 4008. Half is outside. And then can you put the half in again? When you put the half in, what do we get? Half into minus 4 is minus 2, 0, 0. Half into 8 is 4. So can you see the diagonal? Can you see that we ended up creating a diagonal matrix? A diagonal matrix is a matrix where the main diagonal is made up of elements, while the other elements are all zeros. So, and you can see, do you see that these two, the diagonal matrix, the two elements, are they something that's familiar? Who are minus 2 and 4? Who are minus 2 and 4? Minus 2 and 4 are the, look, minus 2 and 4 are what? Look at this. The 2 lambda values, the 2 eigenvalues. So wasn't it given to you as a theory? I just told you as a theory what? In a diagonal matrix. Okay, in a diagonal matrix, the elements on the diagonal matrix are what? The eigenvalues. Can you see? The elements on the diagonal are the eigenvalues of A. So did we get it properly? Can you see that the elements on the diagonal matrix are the eigenvalues? Is this clear? Okay, so this is how you reduce a symmetric matrix to a diagonal matrix by finding the eigenvalues, finding the eigenvectors, getting the normalized eigenvectors, creating the matrix P, and getting the P transpose, and using this particular equation gives you the diagonal matrix. Are you with me? Okay, so then we multiply the two matrices, right? P transpose into P, and we show that P is an orthogonal matrix. So I took the P matrix and the P transpose, and then we multiplied. So I typed it in the calculator. So I gave the two matrices in the calc. Matrix A multiplied by matrix B, and I got the identity matrix, which means P is a orthogonal matrix. Next one, they say show that the matrix A is given to you. Show that P transpose AP is diagonal. So what do you have to do? Simply. So P transpose means you have to just exchange the rows and the columns, right? The first row becomes the first column. 1 over root 6, 1 over root 6, 2 over root 6. Minus 1 over root 3, minus 1 over root 3, plus 1 over root 3. Because it's P transpose. I'm getting the P transpose here. The next one, 1 over root 2, minus 1 over root 2, 0. So P transpose A is 3 over 2, minus 3 over 2, 1, minus 3 over 2, 3 over 2, 1, 1, 1, 1. P transpose A, P. P is again 1 over root 6, minus 1 over root 3, 1 over root 2. 1 over root 6, minus 1 over root 3, minus 1 over root 2. 2 over root 6, 1 over root 3, 0. So P transpose and A and P are supposed to multiply these three matrices. Are you all with me? So let's multiply. I think I gave, I gave the matrix P. Okay, so P transpose, matrix A was P, matrix B I gave as P transpose. So for matrix C, I will define matrix P 3 by 3, and I will give the matrix A. 3 over 2 minus 3 over 2, 1, minus 3 over 2, 3 over 2, 1. And the last three elements are all 1. Okay, and then it's time to multiply. This was what I gave as P transpose was matrix B. P transpose, this is what I gave here. This was matrix A. Okay, matrix P was, because this is P transpose AP. So P was given in the calculator as matrix A. P transpose was given as matrix B. And A is given as mat C. Okay, and you can't change the order. Okay, so type it in the calculator. I have given all the matrices in the calculator now. So time to multiply options. So mat B, now according to what I have typed here, mat B into mat C into mat A. Mat B, mat C, mat A equals. So we get this 2, 0, 0. Can you see we get a diagonal matrix? Two, 0, 0. 0 minus 1, 0. 0, 0, 3. And then what are the elements in the diagonal? These three elements in the diagonal are your three what values? These are the three eigenvalues. If they ask you to what are the eigenvalues by using the diagonal matrix, your eigenvalues are 2, minus 1 and 3. Are you with me? Is this clear?